are for people that were absent in class on Wednesday. So we're going to go over questions like number 13 and 14 on your homework 1. So you should have finished everything else except for those 2 problems. So what I'd like you to do is get out your investigation of inverse trig functions. That was this activity here that we did a couple weeks ago. And we are going to go over E, F, and G from this worksheet. So investigation of inverse trig functions, get that out, and we're going over E, F, and G. I like to call these ArcTrig triangle problems, and you'll see why in a second. So first of all, I've got cosine of arc cosine of 3 over 5. And my first question for you is, when you have an arc cosine function, what goes into the function? Is it a point or is it an angle? So what goes into the arc cosine function is the point from the unit circle. So second question is, if a point goes in and an angle comes out, so this whole thing becomes an angle, we'll call that angle theta. Go ahead and evaluate that. So find that point on your unit circle and give me the angle that corresponds with it. So you should have figured out that there is no angle on the unit circle that corresponds with 3 over 5 because you can't find that coordinate, 3 over 5, anywhere on the unit circle. So this is what tells me that you have to draw a triangle. So this angle that comes out, I'm going to call it theta. And theta that comes out of arc cosine, that angle has to be between where and where. So the angle that comes out of arc cosine has to be between where and where. So it has to be between 0 and 180. So now the question is, am I going to draw my angle in the first quadrant, or am I going to draw my second angle, or my angle in the second quadrant? So I'm going to go ahead and draw this in the first quadrant, and the reason I'm doing that is because cosine is positive in the first quadrant and 3 over 5 is positive. So I'm going to make a note of that below, and I'm going to say, first of all, I know to do a triangle because 3 over 5 is not on the unit circle. So that's what tells me that it's a triangle problem. Second of all, 3 over 5 is positive, and cosine is positive in the first quadrant. So that's how I know to draw the triangle in the first quadrant. Now that we know that we've got our triangle in quadrant 1, I'm going to start labeling parts of the triangle. Now, cosine is what over what, if you're thinking about SOHCAHTOA. So cosine is adjacent over hypotenuse. So that means that 3 is the adjacent side and 5 is the hypotenuse. So I'm going to go ahead and label that in my triangle, adjacent and hypotenuse. Now, how do you find the fourth side of this triangle? Well, it's a right triangle, so you can use Pythagorean's theorem. So go ahead and find that, the third side, sorry, not the fourth. So you set it up, 3 squared plus b squared equals 5 squared, and b ends up equaling 4. So that's our fourth side, or our third side. Now, we had said that arc cosine, you input a point and you output an angle theta. So the theta that comes out is right here. And we don't know what theta is, but I know that in the end, what I'm doing is just finding cosine of theta, because the problem says cosine of this yellow part And if the yellow part is theta, then I'm finding cosine of theta. Now we don't know what theta is, but we've got this triangle drawn. So what is cosine of theta going to be? So cosine's adjacent over hypotenuse, so it ends up being 3 over 5, and that's just your final answer. That's it. All right, second problem. So I want you guys to go ahead and try and set this one up and solve it on your own. And I know that this is going to be a triangle problem because in goes a point and out comes an angle. I'm going to call the angle theta again. And I know this point is not on the unit circle, and that's what tells me that, okay, I have to draw a triangle to illustrate this information. So which quadrant is my triangle going to go in? Okay, so the quadrant is going to go in the negative first quadrant down here. And I know that because the sign is negative, and the angle that comes out of arcsine has to be in between negative 90 and 90. All right, knowing that, sine is opposite over hypotenuse. So my opposite is going to be negative 4. My hypotenuse is going to be 7. Now, the reason that's true is because the hypotenuse, what it represents is a radius of a circle. And a radius is never negative because it represents a distance. So I'm going to put that as a note down here. Hypotenuse is always positive. Now I'm going to go and find the missing side for my triangle, and we do that using Pythagorean's theorem again. So we've got negative 4 squared plus b squared equals 7 squared. That ends up giving you square root 33. And I'm going to leave that positive because it's on the positive side of the x-axis. So once again, this part here, this arc sine, outputs an angle. That angle is theta here. So what I'm really finding is cosine of theta. And using the triangle, what is cosine of theta? Well, cosine's adjacent over hypotenuse, so we got square root 33 over 7. That's your final answer. Now, last problem we're going to do here is a little bit trickier. I know you're going to enjoy it. So we've got sine of arcsine 5 over 13 minus arc cosine negative 3 over 5. So once again, in goes a point, out comes an angle. I'm going to call that angle theta. And again, 5 over 13 is not on the unit circle, so I'm going to have to draw a triangle to evaluate this. Again here, in goes a point, and out comes an angle. And this time I'm going to call my angle x, just to use a different variable. So really what we're finding here is, let's change the color. This part is all theta, and this part here is all x. So what we're evaluating is sine of theta minus x. And this should remind you guys of those formulas that we used last unit. So if you pull out that little half sheet that had all the formulas on it, we had a difference formula for sine that was sine of alpha minus beta. And in this case, we've got sine of theta minus x. So that becomes cosine theta sine x minus sine theta cosine x. Okay? Actually, I'm going to rewrite this just to be consistent with what's on your sheet. that becomes sine theta cosine x minus cosine theta sine x. Now, I would argue that we can now evaluate sine theta cosine x and cosine theta sine x, but then we need our triangles. So this first one here, our theta, that comes from arc sine, and it's positive, so that ends up being in the first quadrant. Arc cosine is negative, so that ends up being in the second quadrant. So here's our theta, and here's our x. Sine is opposite over hypotenuse, and if you do the Pythagorean theorem, you get your third side. So I'm going to let you guys work that out. What does the third side end up being? So third side ends up being 12, and that just comes from 13 squared equals 5 squared plus b squared. Arc cosine here, we've got adjacent over hypotenuse. This is -3 because it's going on the negative x-axis. The third side I'll let you work out with Pythagorean theorem, and that ends up being 4, and that comes from 5 squared equals -3 squared plus b squared, and you get b equals 4. Now, over here on your actual problem, sine theta, you can now use your triangle to evaluate. Same thing with cosine x, cosine theta, and sine x. So my sine theta, sine is opposite over hypotenuse, so this becomes 5 over 13. Notice that the sine is gone and it's just 5 over 13. Cosine x, -3 over 5, minus cosine theta, 12 over 13, times sine x, 4 over 5. We multiply these together, you get -15 over 65, minus 48 over 65, and that becomes -63 over 65, and that's your final answer. So this should help you finish homework 1. And next class, you guys have a quiz, or sorry, not next class, the class after. You guys have a quiz on homework 1. So please come see me if you have questions that you need help with.